I would like to prove that e to the x times e to the y is equal to e to the x plus y by making use of the power series that represent e to the x. That power series has a pattern in which we have x raised to a power divided by the factorial of that power. I use the distributive property to prove this by multiplying each term times each term in the multiplicand. So the product of this first one represents this line, the product of this times the multiplicand represents the next line, and so on. By indenting the lines, a pattern emerges where I notice that when I add the exponents, I get the same number here, 2, here, 3, etc. And I know from the binomial expansion that this pattern can be replaced by y plus x to the squared raised to the second power divided by 2 factorial. Using that pattern again, I can see that this would be replaced by this, except the 2 being replaced by the 3. I then observe that the pattern that this has is the same as the pattern of e to the x, except wherever I see x, I have x plus y. And so making that substitution, I have e to the x times e to the y is equal to e to the x plus y. To give you the foundations, I go back to the basics. First, I have my Pascal triangle, in which is generated by adding the term above the number of interest to the term to the left. So 3 is equal to 1 plus 2. I also discover that I can replace these numbers by factorial equivalence, where I know, for example, that 3 factorial is equal to 3 times 2 times 1. And if I then replace 3 factorial by 6, 2 factorial by 2, I get 6 divided by 2 is equal to 3. So this term here represents the 3. And I can show that for each term. Now I use my binomial expansion, and I square a plus b by multiplying it by itself. Using the distributive property, I get this by multiplying a times this term, and the second line by multiplying b times this term. Exactly the same process I used in my proof. I then add these, where a plus b and added to a plus b, basically 2 of them. I then notice that I have a coefficient of 1, 2, 1, which is the same as the binomial, the Pascal triangle. I then replace each of those numbers by the equivalent factorial. Then I factor the 2 factorial out, which is common to all the terms in the result. And I then divide both sides by 2 factorial, replacing this by a plus b squared. And I get a plus b squared divided by 2 factorial is equal to this, which is the expression above without the 2 factorial, since 2 factorial divided by 2 factorial is 1. I then write this in a vertical format, where I can see the pattern that 2 plus 0 is equal to 2, and so on down the line. All of these exponents adding up to 2 in this particular case. By making a substitution of y for a and x for b, and using the commutative property, I can rearrange these in this order. To make it a little clearer, I use the more conventional notation for exponents, and so now I have this pattern is equal to that. I proved that now explains how I was able to replace this by this. The success in this problem had to do with basically pattern recognition, which we had for the exponent, how we laid out the problem so that patterns could emerge and that we could use those patterns to simplify them to get the answer.